Welcome, secondary educators. So if your experience with math was anything like my experience with math, at some point in your mathematical past, somebody talked about radian measure, and you said, why do we need radians? We have degrees. And they said, you're going to need radians in calculus, and so we have to teach you how to do radians because you're going to do calculus. And sure enough, I did calculus, and sure enough, we needed radians, and sure enough, I knew how to use them. But the question of this screencast is why? Why do we need radians in calculus? What does it do for us? And that answer, as so many answers in calculus class, boils down to limits. So let's talk about, this is the unit circle, that's the unit circle, and let's have some ray at some positive acute angle theta with respect to the positive x-axis, and let's have this perpendicular drop from this point here to its foot over there, and let's run the tangent here. Let's run the tangent like so. So if you're keeping track, this radius is 1, this radius is also 1, all of that becomes relevant. Let's think about the area of this sector right here. We know that the area of a sector is 1/2 radius, angle between them. But this radius is 1 and this radius is 1 and the angle between them is theta. So as long as we're dealing in radians, the area of a sector is 1/2 r squared theta. Theta's gotta be in radians. And that's a trigonometry thing, and so that's 1/2 theta. Well, the area of the sector is less than the area of triangle ODC, where O is the origin. So this triangle here, ODC. Well, what's the area of that triangle? Well, the area of that triangle is 1/2 times the base times the height. 1/2 times the base is 1 times the height is tangent theta. And the area of the sector happens to be bigger than or equal to the area of this little triangle, triangle OAB, where O is the origin. It's this small triangle here. And the area of this triangle is 1/2 times its base times its height. And I'm just going to bank on the fact that you saw the last video from the last lesson so that you know why that's true. Well, if this is true, divide everybody by 1/2, divide everybody by sine theta, cosine theta, and you get 1 is less than or equal to theta over sine theta, cosine theta, less than or equal to, this is already sine theta over cosine theta, and we're dividing by cosine theta, sine theta. This turns into secant squared theta. So what does that mean? Well, let's consider what happens as we take this acute angle and bring it really, really close to 0. Let's take the limit as theta goes to 0. As theta goes to 0 from the right, what is happening? Well, secant squared theta approaches 1. So by the squeeze theorem you learned in Calc 1, if this goes to 1 and this goes to 1, the limit as theta approaches 0 from the right of the thing in the middle is also 1. Now, just between us, sine theta over theta or theta over sine theta is an even function, and cosine theta is an even function. And so this isn't just the limit as theta approaches 0 from the right. This is the limit as theta approaches 0 from either side. So that also notice that cosine theta goes to 1. So the limit as theta approaches 0 of theta over sine theta is the limit as theta approaches 0 of sine theta over theta, and both of those are 1. Similarly, we can prove that the limit as theta approaches 0 of cosine theta minus 1 over theta is 0. We can prove that in a similar way. So now it's time for the who cares. Time for the who cares. Let's take the derivative of the sine function with respect to x. How do we do that? Well, it's the limit as h approaches 0 of the sine of x plus h minus the sine of x over h. And we know, because we've been doing trig formulas, that the sine of x plus h is sine x cosine h minus, plus cosine x sine h minus sine x over h. And we can do a little bit of creative algebra, bring the sine x's all together and factor them out. Cosine h minus 1 over h. And then this part over here is cosine, that's an x, cosine x times sine h over h. So what happens? Cosine h minus 1 over h goes to 0. And from the previous slide, sine h over h goes to 1. So what's this limit? This limit is sine x times 0 plus cosine x times 1. The derivative of the sine function is the cosine function. This is well established. Well, let's ask the question. What if we use degrees instead? So the authors of your textbook say, let's let S of theta and C of theta be the sine of theta degrees, or the cosine of theta degrees. So it's not the sine and cosine functions you're used to, it's the sine and cosine functions if we were measuring in degrees. Now, let's go back 2 slides. What's the area of the sector? Well, the area of the sector, we've got to convert theta to a degree measure. So it's not 1/2 theta anymore. It's 1/2 theta times pi over 180. 1/2 theta times pi over 180, which means all of this shrinks down and you don't get a 1 here anymore. You get a 1 times pi over 180 here. So the limit as theta approaches 0 degrees of sine of theta degrees over theta degrees is 1 times pi over 180. We make the conversion to degrees. We make the conversion to the area formula in degrees. So clearly, if you cut out a sector with 1 degree as the angle of rotation, that's much less than if you cut out a sector of a circle where 1 radian is the angle of rotation. The cosine is unaffected because that goes to 0, and 0 is 0 no matter what. So then what happens here? Well, this still goes to 0, so this part still drops out. This part goes to pi over 180. So the derivative of the sine of theta degrees is pi over 180 times the cosine of theta degree. Oh, that's a theta. Golly, you're going to catch me on that. That's a theta. The derivative with respect to theta of the sine of theta degrees is the cosine of theta degrees times pi over 180. So can we do calculus in degrees? Sure. Do we have to always convert? Yes. And so we don't use radians because we don't want to do that conversion. We don't use radians because they're less elegant. Degrees are less elegant. Radians are more elegant for the things we want to do in a calculus class. Well, I hope that's helpful. I've gone past my 10 minutes, so you've probably shifted to cat videos by now. But I hope that this was sort of helpful, and I'll see you when we gather.